Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2017 Maths Methods Exam 1, Northern Hemisphere. These are my suggested solutions. Yeah, I hope these solutions can help you understand some concepts. And yeah, before I start, like always, if you guys want private tutoring, you can always email me through this email. It will also be in my link in the description. Let's go through this paper. Question 1, let y equal this, dy dx as well. Okay, so u is e2x. V is cos x over 2, so dy dx is equal to e2x negative half sine x on 2 plus cos x on 2 multiplied by 2e 2x. So final answer to dx is e2x can take as a common factor, so we say e2x negative half sine x over 2 plus 2 cos x over 2. Yeah, looks good. So let f of x be this and evaluate that. Okay, straight away you should know that when you have a log e and a function like f of x, the derivative is f dash of x over f of x. So for this one, f dash of x is, what's the derivative of sine? It's cos x over sine x. So what's f dash pi on 3? It's cos pi on 3, which is half over root 3 on 2. So half times 2 root 3, which is 1 root 3. For methods, you don't even need to rationalize, so yeah. Or you can rationalize as root 3 on 3. Perfect. Done. Find the antiderivative of this. So cos 1 minus x dx is what? Well, okay. 1 over the derivative of the inside, which is negative 1. Sine 1 minus x. So cos 1 minus x dx is negative sine 1 minus x. Have I made any mistake here? So yep, looks good. Yeah, evaluate this. So this one, I'm just gonna square bracket and say 3x on 3 over here. Okay, so I'll just put that power up, so negative 2. Add a power, so it'll be negative 1 divided by negative 1, so it'll be negative 4. So it'll be negative 4 over x actually. So negative 4 over x, 2 to 1. Okay. So that'll be, if I'm gonna just cancel out, so let me just, it would just be x3 over here. Okay, so we're saying 8, so it'll be 8 minus 2 minus 1 minus 4, which is 6 minus negative 3, which is 9. Alright, so your final answer, we write it 1 on 3, or 1 on 2 actually. 3x squared plus 4x squared dx equals 9. Find f of x given that this and that, so easy. So the derivative, antiderivative of 3 over 8 x squared minus 10 x negative half plus 1 dx is what? So this, okay, let's just find the antiderivative of this. So it will be, just take that constant out 3 times. What's the derivative of this? Antiderivative of this? It's x3 on 3. Okay, so multiplying both of these, those cancel out, so it'll be x3 on 8. So write that, x3 on 8. Let's do that for the next one. And for negative 10x negative half, pull that constant out, times x negative half. Okay, so if we add 1 to the power, it'll be half, and we have divided by a half, which is just multiplying it by 2, so it'll be negative 20, pretty much root x. Yeah, so negative 20 root x. And what about that one? It's just plus x. From, yeah, so plus c. So therefore, that'll be x3 on 8 minus 20 root x plus c, given that f of 4 is 25. We can say that. So we're saying 64 over 8. So this will be 8 minus 20 times 2, which is 40. This will be 40 over here. Plus 4 plus c must equal 25. So 12 minus 40 plus c equals 25. That will be negative 38. Oh, no, sorry. Yeah. I'm at negative 28. So negative 28 plus c equals 25. I'm at negative 38 actually. What am I saying? Okay, so wait, am I I don't know what's happened to me. Wait. So negative 28. Okay, so negative 28 plus c equals 25. Perfect. That's it. Yeah. So c is 25 plus 28. C is 50. So that's 8 minus 5, 3, 53. Okay. So now that's going to let us know that the integral for 3a8 x squared minus 10x negative half plus 1 dx is equal to x power 3 on 8 minus 20 root x plus 53. So that's your actual final solution. Damn, that's a big one. Let's move on to the next question. State the smallest positive value of k such that this is a solution to this. So if we sub that in, so it's tan 3 pi over 4 equals cos 3 pi k over 4. So this can be simplified as tan pi minus pi on 4, which is what? So if you look at here, this is pi, so it's around here, CAS, so it'll be negative tan pi over 4, which is just negative 1. So I take this off. So this here is negative 1 cos 3 pi k over 4. So what's cos inverse of negative 1? 3 pi k over 4. So cos, if I sort of draw a cosine graph, and the positive, because we want the positive, when does it equal negative 1? At pi. That's the smallest one, so we can say that's pi, 3 pi over 4k of this. So 1 equals 3k over 4. So k is equal to 4 over 3. Done. Is that right? Yeah, it looks good. Solve this. Okay, straight away I know that I'm going to let u equal sine x. So it'll be 2u squared plus 3u plus 3u minus 2 equals 0. So u 2, oh, actually put a 2 here, so that's to. Wait. If I put a 2 over here and 1 here, I'll put a minus here, so 4 minus, yeah, perfect. So this will be 2u minus 1, u plus 2 equals 0, u equals half, and u equals negative 2. So we're saying sine x is half and sine x equals negative 2. Now, this is rubbish. Sine x equals negative 2 because sine is only between negative 1 to 1. So we cancel that out. So only sine x is half, which, so if I say CA, so here S, so we can say x is, what solutions? Pi on 6, and what's pi minus pi on 6? 5 pi on 6. Yeah? So pi minus, yeah, 5 pi on 6. These are your two solutions. Next question. So f of x is this. So it's tan 2x plus 1. All right. And sketch the graph of... So what I'm going to do is I can easily sketch just tan 2x and then just overall translate it 1 unit. So what I'm going to do is I'm going to say what's the period. So it's pi over 2. So and divide that by half. It's going to give us the first asymptote. So pi over 4. So we can say here x equals pi on 4. And also at, by symmetry, x equals negative pi on 4. Now, we should know that the graph is going to start here, and it's going to go looking like this. It's going to look like this, look like this, look like this. And yeah, make sure you include them because they are included. Okay, and then what we're going to do is we're just going to translate everything 1 unit up. I take this, 1 unit up is over here. Well, let me just translate this whole thing. 1 unit up, right over here. 1 unit up, right over here. Nice. So the graph looks like this. I don't like this. Let me just write that out. Make it shorter. Perfect. So, and what else? Sketch a graph of f, label any asymptotes, yep, with a appropriate equation, label endpoints, so that'll be pi on 2, 1, negative pi on 2, 1. Axial intercept, so this one here is 0 to 1. And so x-axis, so if I solve it, let me do a quick solve. So tan 2x equals negative 1, so CAS, so here. So we can say that 2x, pi on 4 is your base angle. So we can say pi minus, oh, be careful actually, wait. I forgot the domain. So we want it from negative pi to pi. So we want it, the solutions to be, negative pi over 4 as the first one, and pi minus pi on 4. 2x, yeah, so negative pi over 4, 3 pi over 4, which final answer is negative pi on 8, and 3 pi on 8. So it's over here, negative pi 8, 0. And this one over here is 3 pi 8, 0. Done. We've done that. Perfect. Let me just write this off. Alright. Is that it? With the coordinates. Done. Use the features of the graph in part A to find the average value of f between negative pi over 8 to this. So we know average value is 1 over, so pi over 8 minus pi over 8, which is just pi on 4. Integral from negative pi on 8 to pi on 8, 10. Oh, yuck. Nah. We're dealing with tan. It's only 1 mark. Absolutely rubbish. So there has to be a way. So what about if we use the graph? What if you use the graph to advantage here? So, okay. So negative pi 8, which is this over here, to pi over 8, which is over here. If I sketch a line here by symmetry, we want this, so we want 1 over pi of 4, which is just 4 pi, remember? And so 4 pi, so 4 over pi, and the area. So what's the area? Well, have a look at this. What do we know? What can we know? Well, we can see that this area over here, this square, is 1 square. That's 1 square. And by symmetry, by symmetry, if I was going to draw a line here, this is supposed to be a square 2 here. So it means, aha, wait. So this, if I sketch this nicely, actually, if I was supposed to check it nicely, this is supposed to look like this. Like, it was supposed to look like the same as that. So I can say by symmetry, oh no. So by symmetry, if I say that's 0, 1, this point to this point, okay, wait. What was this? So, okay. What am I supposed to say? This area is supposed to equal this area. That's what's supposed to happen, actually. But I didn't sketch it that nicely. Yeah. So that area is supposed to look like this area. And then we also have a square. So if I add these two areas up, it would just make a full square. Yeah. So we have this square and this square. So two squares. So we can say two squares that have a pi on 8 to 1. So what's pi 8 times 1? Just that. Yeah, that's the actual thing. So 4 pi on 4, 1. Is that it? Yeah, 1. Let's double check it. The way that I would double check it is to really look at it like this. That's 0, 1. Okay, if I was going to... Well, it makes actually sense. I mean, let's just look at the symmetry. If I was going to draw... What's the average? Like, what's the average from everything over here? Well, it's 1. Normally, yeah. Like, normally when we have what's the average value of cos x? Well, if we draw cos x, the average value is 0. Here, the same thing, but it's just been translated 1. So the actual average value... So normally if it was just not translated, it would be... The average value would be 0. Because it's translated 1 unit, it's 1. Yeah, nah, makes sense, absolutely. That's good. Done. I could have just, said 1, but I don't know why I should this much working out for what. Because records of the arrival times of trains at a busy station have been kept for a long period. The random variable x represents the number of minutes after the scheduled time that a train arrives at this station, that is the lateness of the train. Assuming that the lateness of one train arrives at this station is independent on the lateness, so we're going to use binomial. The distribution of x is given by this thing. Find the value of p. Okay, so if you add them all, so 0.8, so we can say 0.8 plus p equals 1, p 0.2. Expected value, okay, so expected value of x is -1 times, I will change them all to fractions, makes my life easier, plus 4 times 1 on 10. Oh, what am I doing? Ugh. So yeah, -1 times this, that will cancel out. So then we say 3 on 10 plus, what's 2 times 2 on 10? So 4 on 10. So we're saying what's -1 on 10 plus 7 on 10, 6 on 10, which is just 0.6. Yeah. Well, we just need the answer. I'm just going to put 0.6. That's that. 0.6 is your thing. What's your variance? Well, variance, because we have an expected value, variance is expected value x squared minus expected value this. I think all squared, sorry, I forgot the all squared. So what's -1 squared? So it's just 1. Then 1 times, so that'll be 1/10. Plus, that's nothing. 1 squared, yep. So that'll be 3/10. 2 squared, which is 4. What's 4 times 2 on 10? So 8 on 10. Minus, okay. Everything squared. So for example, expected value. Well, our expected value is 6. So 6 on, what's 6 on 10 squared? 36 on 100. So what's 8, 9, 10, 11, 12? So 12 on 10 minus 36 on 100 which is like saying 1.2 minus 0.36. I don't know what I'm doing. Wait. Alright. Okay, wait. 1 on 10. Plus 3 on 10 plus 8 on 10 minus 36 over 100. And we add those up, we get this, so that'll be 1.2, yep. And the other one here will be 0.36, yeah. And then what's that? Well, that's equal to, if I add, for example, 0.64 plus 0.2, 0.84. Is that right? 0.84. Yeah, so 0.84. Hope that's right. A passenger catches a train at a station of 5 separate occasions, so n equals 5 straight away. What is the probability that a train arrives before the scheduled time on exactly 4 of these? Okay, so before, these are after. Before is -1, that negative because he's become before that time, so it's 0.1. So we can say that x, x is binomial from 5 people to 1 on 10. So we can say, what's the probability of x equals 4? 5 choose 4. 5 6 is 1 on 10. 4, 9 on 10, 1. So if I do this, 2, 3, 3, 1, 6, 4, 4, 1, 10, 10, 5, 5, 1, 1, 0, 1, 2, 3, 4. So it'll be 5. So this will be 5, 9 over 10 to the power of 5. Do we have to simplify? Well, it's just, yeah, like a 45 over 10 to the power of 5. Yeah, that's that. Do we simplify this? I mean, you can, but I don't think it's important. Yeah, you can say 45 times 10 to the negative 5 then, if you wanted to simplify it. Or, actually, you can, 4.5 times 10 to the negative 4. Which, if you write 4.5, so I'm going to put some zeros. So 1, 2, 3, 4. We can simplify this whole thing to 0.00045. That's that. Yeah, you can simplify it to that. Okay. Hope that's right. At a large sporting arena, there are a number of food outlets, including a cafe. The cafe employs 5 men and 4 women. 4 of these people are rostered at random work each day. Let P represent a sample proportion of men rostered to work on a particular day. List the possible value of P. This is a proportion. Okay, so 4 of these people, so n equals 4, or are chosen at random that day. Let PB represent the men. So men, how many men? 5, yeah? So, so men, probably men is just, let's say P is men. It's 5 on 9. Yeah. So we want let P represent the proportion of men. Well, the proportion, we know that proportion is x over n. So, and there is, we need 4 men, because it's only 4 people we can take. So the first P value we can take the values of, if we put first x equals 1, because so for n's 4, but let's say 1 first, so 1 on 4. If you put 2, it'll be half. 3 over 4, 1. And 1's 4. Is that right? These are your proportions. What about 0 actually? So if I put a 0, 0 over n is 0. But it only says 4. What are the proportion of men rostered to impart there? supposed to, I think, only have 4, so you're not supposed to, yeah, have that. Yeah. Are we allowed to have 0? Yeah, we can have 0 in real probability, but is that part of the thing? I think, yeah, you gotta have to put 0 because we can also have 0 men. Like, list of possible values, yeah. We can have 0 men that work. Which gives us this. Let p equal 0. Okay. So if we have a tree diagram, say female, male, in the first, because we're choosing 4, like 4 n needs 4, so we can do female, male, female, male, female, male. But we want, where p is equal 0, so we want 0 men, actually, yeah, 0, so all females, all the 4 people female, so just do for this, we just need this over here. And remember, it's not replaced, because they don't say it's replaced, first it's not binomial, they haven't said anything about independency, and also, yeah, and it makes sense, well, you can't replace it, you know, if a girl's working or a woman's working, you cannot have the same number of women working, it decreases, so how many women? Probability, so 4 out of 9, so 4 and 9, that'll be here, 3 on 8, 2 on 7, 1 on 6, and multiplying all of them together, probability of p this equals 0. What's 4 on 9? 3 on 8, 2 on 7, 1 on 6. That's 3. That's 2. That's 3. So it'll be 1 over 7 times 3, 7, 40, 21, 21, 42, 3, so 3, 6, 4, 8, 12, 1, 2, 6. All right. What's that? This is a mess. This is a very much mess. Ooh. Yeah, like that. Have I done anything wrong? I'm not too sure. Yeah, we include 0, yeah. I mean, it makes, yeah, we had possible value of p, which is 0. Oh my god, what am I talking about? 0 is included. Alright. There are over 80,000 spectators at a sporting match at an arena. 5 in 9, so 5 on 9 of these spectators are Gorner's team. So probably that's like a probability. A simple random variable, this 2,000 spectators selected, so that's your n. 2,000, not this one. These are your actual population. This is your sample we want. What is the standard deviation of distribution of p hat? The sample proportion of spectators who are this. Okay, easy. So SD for p hat is easy. So you should know the formula. It's in your formula sheet. It is p hat, well, minus p hat over n. So it will be, well, 5 on 9, 4 on 9 over 2,000. So 5 times 4 is 20, 81, divided by 20, so times 1 over this. These 20 cancel out, so what's 1 over 81 times 100? So 1 over 81, this. I'm taking the square root of that is 1 over square root of 9 times, square root of 9 squared times 10 squared, which is just 1 over 9 times 10, so 1 on 90. That's that. Alright. Done. Alright, let f of x be this, g of x be this, then this. Okay, easy. So g f of x is what? So g is our function, so 4 minus 2, 2x, 3 plus 1. Yeah, I think we don't need to simplify that, do we? Well, yeah, no, I don't think we need to simplify it, so keep it that way. Find g of x and express it in this form. Okay, so f g of x is 2, 4 minus 2x to the power 3 plus 1. And we can take, because we want this x to be positive, so we can take a common factor of -2. So it'll be -2 here, plus x, power 3 plus 1. So it'll be 2, -8, -2 plus x, 3 plus 1, -16, x minus 2 to power 3 plus 1. So getting that form, it'll be fg of x 1 minus 16 x minus 2 to power 3. Done. Yeah. The transformation with this rule, where a and b are c are integers, transforms the graph of g f of x, so this, onto the graph of this. Okay, so I'm just going to expand this. So x dash x plus b, so that'll be x is x dash minus b, and y dash ay plus c, so your y equals y dash minus c over a. So we're going to shove those into this function over here to get this. Alright, so what is, okay, what is g f of x? So g f of x is that expression. Okay, so y minus c over a equals 4 minus 2, so 4 minus 2, 2x 3 plus 1, this, and that x, we want to replace it, x minus b to the power 3 plus 1. Okay. Let's just expand it. So y minus c equals a. So 4 minus 4. X this minus b 3 minus 2. Okay. So multiplying everything by a, so y minus c, everything by a, so it'll be 4a minus 4a, x minus b 3 minus 2a, then plusing c, 4a minus 4a, x minus b 3 minus 2a plus c. And yeah, so now we can just equate. So for example, -4 a x minus b 3 plus 4a minus 2a plus c. And pretty much this over here is just 2a. Okay, and put that there. So looking at what? Fg of x, well, we can equate this to this. So we're saying -16 equals -4a, so a must equal to 4. That's your first value. Let's put that there. Done. Your next thing that we can equate is your b. Here, it should be 2. b is 2. What about this value over here? Easy. So 2a plus c must equate to 1. And we know what the value of, 8 plus c equals 1. C must equal to -7. So c, -7. That's that. We are done. Those are the values. That's it. 3 marks. Wow. That's good. Move on to the next questions. Okay. The rule for a function is given by this, where f is defined as its maximum domain, find the domain, and the rule of the inverse. So what we're going to do is we're going to let f of x equal y, interchange f of x, interchange 1 and x. So that will mean x square root 2y plus 3 minus 1. So x plus 1 squared 2y plus 3. So it'll be x plus 1 squared minus 3 all over 2 your y. So we can say f inverse of x is x plus 1 squared over 2 minus 3 over 2. And your domain of the inverse is the range of this. So if I'm going to sketch this, it's going to have -3 on 2 and -1. So it's around here. And it's going to go like this, or something like this. And this point is -1, so we can say it goes from -1 to infinity. So your dom of inverse is the range, so -1 to infinity. Yeah, perfect. Those are that. Easy. Move on to the next question. Solve f of x equals the inverse. Okay, this is the most easiest. If you really look at it, it crosses. So if you have something like the inverse, for example, if you had the inverse of this, the inverse will look like this. And what they do is they always cross y equals x, the intersection. So what we can just do is we can just say f of x, well, 2x plus 3 -1 equals x. We can let that and we can solve. So we can say that's x plus 1 squared 2x plus 3. So it'll be x squared plus 2x plus 1, 2x plus 3, x squared plus 1 equals 3, x squared equals 2, x is plus or negative root 2. But be careful, our maximal domain, oh, what did I do? Okay, our maximal domain for the solutions is, if you really look at this, we're going from -3 to 2 to infinity. That's the domain of one of the functions. Also, but also another domain is this for the inverse, which is -1 to infinity. So we can only take the positive. So x is root 2. Yeah. Done. X is root 2, yeah. Perfect. Next question. Okay, this is the last two. The last two are always going to be hard ones. Okay, let g of x be this. So it's the same, but there's a c, where d is the maximum domain of g and c is a real number. For what values or value of c does g of x and g of x have no real solutions? No real solutions. So let's do the same thing. So if I say this, 2x plus c minus 1 equals x. 2x plus c, x plus 1 squared, 2x plus c, x squared plus 2x plus 1, c must equal x squared plus 1. Now if I draw x squared plus 1, and so x squared plus 1 is this, and it goes like that. And this is 0 to 1. So c is a line, so we want no real solutions, so we want c to be less than 1, but not equal to it, because if it's equal, it actually becomes a solution. So be careful of that. So we can say c. So yeah, so c is less than 1. That's that. Just that. For what values of c does this have exactly one real solution? So one real solution is, yeah, so if we want one real solution, it's just as c equals 0. Yeah? So c equals 0, yeah. So at c equals 1, sorry. C equals 1. What am I saying, dude? C equals 1. Is that right? See, this is why I'm just kind of confused, because it's the last question, and you know this last question, it's supposed to be the hardest one because there's a trick into it, and it's 2 marks. So there's a trick into it. There has to be something extra because they're giving you 2 marks for the last question and it was this easy just to get the marks from this. So no, absolutely not. So what can we do? Well, I have no idea. What I'm thinking I'm going to do is I'm just going to graph and plot some graphs and see how the graph changes and maybe we can estimate what. And it says, yeah, so if I just draw, let's say big actually, let's draw a kind of a big, well, we're only taking, so we draw it from here. Something like that. Okay. So, what do we know? No, that's not nice to draw like that. So let me just draw it nice. Okay, what are they trying to trick us with here? So, if I look at this point, let's say that's 1, that's 2, that's 3, that's 4, that's 5. That's 1, that's 2, that's 3, that's 4, that's 5. 1, 2, 3, 4, 5. 1, 2, oh, it's too small. 2, 3, 4, 5, 6. Okay, so we know that when c equals 1, what's c? So we know that when c equals 1, that's going to give us one real solution. And when c is less than 1, it's going to give us no solution. So we should just try out where c is greater than 1, like c equals 2. Let's try c equals 2, just as a guess. So let's say c equals 2. So when c equals 2, it means, let's take both equations. So we have 2x plus c minus 1 equals y. That's the equation. And what about the other equation? Well, we can actually just guess it because we've already can have a similar look at this. So c is, in this value, c is 3. So it's just going to be x plus 1 squared over 2 minus c over 2. Yeah, because that 3 is just there. So yeah, just pretty much this. I'm just going to copy that, cut that, and bring it there. And write it nicer. So x plus 1 squared over 2 minus c on 2 equals your y. So these are your actual inverse. And let's do different colors. Okay, so let's draw when c equals 2 for this. So if c equals 2, we're saying 2x plus 2 equals minus 1. So negative 2 over 2. So negative 1, negative 1. So that's where your reflection is. So negative 1 to 1. So right over here. And if I now, yeah. So if I now sub in, say 0, for example, it's root 2 minus 1, which is around 1.4 minus 1, which is 0.4. So it's around here. What about if I put in sub in 1? So 1 would be 2 1, so it'll be 2 plus 2, 4, square root for 2 minus 1, 1. This is supposed to be 1. What about 2? So 2 times 2 is 4, root 6 minus 1. So it'll be like 4 minus 1, let's say, which is what? Like 1.4. Yeah, 1.4. Let's say it's 1.4, which is like 1.5. And let's draw y equals x, actually. We didn't even draw y equals x. So if I'm going to draw y equals x, it's going to be the easiest one to draw because it's just, we just have to draw 1 and we can just reflect it. Wow, is it so, oh my god. Or something like that. Like this, like this, like this, like this. And just draw the graph. Nice. And that's y equals x. So let's continue. So 3, what about 3? 3 times 2 is 6, root 8 minus 1. So that's 2 minus 1. So 2 times 1.4, 2.8 minus 1. Maybe, so 1.8. 1.8, which is around this value over here. So yeah, something like that goes like this, like that. And then where it intersects this, we're going to have a similar graph. Oops. Come on, we gotta go quick. This. Okay, it's gonna look like this pretty much. So when C is equal to 2, so when we're going greater, we can see that we still get 2 points of intersection, so that's still not good. What about C equals 3? So C equals 3, let's try that. It's quick. So if I call C equals 3, let's just try everything out. So now let me rub this all off. C equals 3. Oh my god, such a pain to rub this. Okay, if I just rub this quickly off. Alright. Something like that. Okay, so let's do C equals 3. So when C equals 3, what happens? Well, we get... so we just have to draw 1. So 2x plus 3 minus 1. So negative 3 on 2, negative 1. So it'll be over here, negative 1. So around this point over here. Okay. And so if we sub in negative 1, 2, so square root negative 1, so negative 1 plus 3. 1 minus 1, 0. So here, it'll be 0. What about 0? If we sub in 0, so square root 3 minus 1, which is what, like 1.7 minus 1, or 0.6, or maybe 0.6, somewhere around, yeah, something like 0.6, around here. And what about just 1? So if we sub in 1, root 5 minus 1, which would be like 4 minus 1, so 1.4, 1.4, let's say 1.5, safe. Something like, it will look like this. So the graph, wait, what's this? So if we just we draw this, this, and this, and this, so what can we see? Well, let me actually draw in a different color. Wait, there's only 1 point of intersection now. So when C is equal to 3, okay, what about C equals 4? With that, so we know what's happening is the graph, this, is just going like this. So if we increase it, then this over here decreases. And we still get more intersections. Decrease it more, and this one decreases. We still get one intersection, I think forever. So it only hit when we were saying it's, when we said 2, so when 2 was negative 1, so when we said 2 was negative 1 over here, negative 1 over here. So when C was equal to 2, we got that, and when C is greater than 2, we get one solution again for all of them. So when C is greater than 2, we get pretty much, yeah, one exact real solution. See, this is how you should know. When they give you the last question, don't think it's that easy. Always look at it. They're trying to trick you. The last question is supposed to be the hardest question. So yeah, this is how I did it, to be honest. Hope you guys enjoyed this video and learned something. Have a good day. Bye-bye.